Completed a first batch of linear algebra problems in Anton, and yeah, so in this case I have already read chapter 1 from way back when, and this is going to be in a playlist where this will actually be the second video, because there is a first video with a different edition, but it's the same content back in 2022 when I read all of chapter 1. So I worked on sections 1.1, 1.2, a lot of problems. So this particular work in linear algebra, there's going to be some reading, but mostly it's going to be problems, which is great. Another thing that I'm doing, look at all the problems that I'll be able to work on, is setting up a pace. So for now, for the first step, first week, my pace is to be finished by May 31st, and I have done that. But I can foresee where, these are all the Fridays in the next 31 weeks, where I'll be off in these. And if I get a little late, that's fine. I'll go into January, not a big deal. But there should be enough slack in this schedule for me to be able to also do the reading. So we'll see how that pace goes. But I learned from the Baby Rudin project that if I want to do a lot of problems, I need to allow the time to do the problems. The reading takes time, but the problems take way more time. And this is why, basically, if I want to do a lot of problems in this book, I will be working on it for the rest of the year, and it will be the only book that I work on, which is great. Another mistake that I made in Baby Rudin of doing too many books, even though it was a lot of fun. So here we go. So those are the problems right there. And then I'll show my notebook, and I also have answers, some in the back of the book, but also some answers in the booklet, the little booklet, the exercise booklet. And so that helped as well. The book reads very well, and yes, and I'll be saying it in every video that I make, tons and tons of problems. Once you get down to the last few problems in every section, they get harder. Yeah, they definitely get harder. And yeah, so the way that I usually have solved matrices is really a Gauss elimination, which is the one where you get to the point where you have all these values and you start just going up with all the variables until you get to the top. In the case, the book makes a distinction that you can do it this way, but you can also do it completely. And when you do it completely in Gauss-Jordan elimination, you go all the way through. So just by habit, from having done linear algebra and engineering, I usually do it this way. As soon as I can get to the point where I have a value here, I just start plugging in and get to the top. This one had some true and false the answers. Somebody wrote them. That's a shame. But yeah, so that's those two sections. So I'm going to show the actual work itself graded, because I went through for the odd problems. I tried to do as many even problems as I could as well, but towards the end, when I knew I was running out of time, and I think I'm going to be timing myself just so I can finish everything on time by the end of the year, by the last day of 2024, I would do evens and odds all the way until almost to the end, and then at some point I'd be like, all right, this is where all the hard problems are, I'll just do the odd ones. And check marks mean that I got it right. But yeah, you will see many of all the lower even problems have been worked out or attempted. And of course, a major shift from all that analysis work, all those equations, all those theorems, where the ratio of problems to reading was about 4 times as much reading as there were problems. Here it's the opposite by a lot. I think there's going to be 10 times as many pages than there will be for problems. So for example, this is way back when, from 2022, when I did chapter 1 reading. Chapter 1 reading for this book is 46 pages. I'm only in the first 2 sections, and I'm already at 44 pages. So the ratio is going to be completely flipped, which I love. This is something that I've been wanting to do this for so long, because even though I love analysis, I really was rearing to go to do linear algebra. So yeah, where I put revisit, I missed the boat. and I got to go back and check. And I did that a couple of times. Not too many. Not too many. Slowly getting better in my little forgetting minus signs, which happens when I think in my case I'm doing the shift from a lot of theorem writing, a lot of theorem proving, to actually just simple arithmetic of figuring out all these matrices. And of course, for some problems, they got complicated, and I tried and I tried multiple times until I got it right. But yeah, and then also I'm training myself with all these matrices to be able to track my work carefully enough where I know, okay, up to this point, I know I'm right, but I did something wrong in here. And sure enough, so I'm training myself to pick up when a problem is difficult and takes many, many steps, to go, all right, I'm pretty sure these steps are right, but I know I screwed something up in here because this is not working when I do verifications, when I do my checks. It didn't work. Yeah, so I'm learning to do that. I'll get better at this game of keeping neat, worked out solutions as I plod along. I did figure out this problem, very happy about it. It says there are 18 solutions, sure enough, because it's trivial and it's all zeros. So it's really, actually it's tangent gamma is equal to 0, cosine beta is -1, sine alpha is 1, and that's where you get 3 times 3 times 2. Well, actually, I think I got a little bit of part of this wrong. I think they're all supposed to equal 0. So I think I made a mistake here. I just realized. Gave myself a little too much credit. And then towards the end of section 1.2, 37, I just couldn't get it. This is the correct answer from the booklet. I tried it many times and I just didn't. And then in the case of problem 39, I got it wrong. I messed it up. And then 41, I laid out some of the forms, but I missed a whole bunch of them, so I have to go back and revisit. And it's just the business of what are all any number, and then how do you put all these matrices so that it's reduced row echelon? How many are there of the type? For the proof of possible reduced row echelon forms, I also missed a few forms, even though I got the second part right. This one, of course, the answers were in the book. I started grading and I was like, of course, I kind of knew what the answer was as I was working them. So there you have it.